I'm UJ-MaGT of the Department of Physics, University of Jos. I'm going to show you today how to evaluate your errors associated with your slope and intercept. In the last video, I showed you how to use the graphing app called UJ-MaGT graphing tool to plot your graphs correctly. So today I'll show you how to use similar app to evaluate your slope correctly. So let's look at the graph we plotted and see how to evaluate the error. If you plot your graph and you determine the slope, the next thing is for you to get the error associated with the slope. So to do that, you use the relationship E of S is equal to 4W over NR. E of S, that is error in slope. Now W is equal to A plus B over 2 or W1 plus W2 over 2, as some books may write it. So how do you get A and B? A and B are the distances, between the farthest points above your line of best fit and below the line of best fit. In this case, our A is this line distance and our B is this distance. So we need to know what these distances are. Now, to do this, you use your graphing tool. So you come to your smartphone, look for your graphing tool, then you go to slope and intercept formula. You enter your scales that you use on your axis. On the vertical axis, we use 0.02. Origin. When you are determining A and B, the origins you use will be 0. Don't use the origin that you use in your plotting. Like in this case, our origin was 0.22. However, in determining A and B, we use origin as 0. Eta is 5. Our I was 4. Though we don't need anything to do with x-axis, but you have to impute the values so that the graphing tool does not crash. So we put 0, we have 5, our I also is 4. Now we set this as constant so that we don't need to write again. Now you come to your graph, count the number of millimeter boxes that represent that line. That is the number of millimeter boxes between this point and this point. Also the number of millimeter boxes between this point and this place. So looking at the number of millimeter boxes that represent your A, if I look at it, I can see 15. Then there are 2 millimeter boxes up there and there are 3.5 here. So all in all, here to here you have 20.5. Here I can also see 15 and I have 2 up there with 3 down. So here, from here to here, you have 20 of the boxes. So you now come to your graphing tool. To get your A, you put 20.5 there. Here you can just put 0 so you can compute. When you compute, this tells you that your A is 0.0205. Now to get your B, you now put the number of millimeter boxes, which is 0, 20 there. Then you can put 0 here for the purpose of computation, and you now compute. This tells you that your B is 0.02. So that's how to get your A and B, and you can come and substitute in your relationship. Now when you add 0.0205 to 0.02, you will get 0.0405, and you divide by 2, you will get 0.02025. That gives you your W. Your N is equal to 5. Your N is the number of points you plotted. So if you look at it, we plotted 5 points. This point, this point, this point, this point, and this point. These are the 5 points we plotted. So your N is 5. Your R is range. The range, to get your range, you take the range of the values that you plot on the horizontal axis. Now you do this, you can come to your table. We put our L on the horizontal axis, so the range is the highest value minus the lowest value, and when you do that you get 40. So when you substitute and you evaluate, you find your error in the slope is 4.05 times 10 raised to power of minus 4. So that is the error in your slope. To get the error on the intercept now, E of I, error on the intercept, is equal to the absolute value of your original intercept minus intercept 1 plus the absolute value of your original intercept minus intercept 2, everything all over 2. And when you do that, you will find out that it's equal to almost A plus B all over 2, which is almost the same with the W in your errors, slope errors formula. So how do you get your I1 and I2? That is the intercept 1 and intercept 2. To do that, you draw a parallel line to your line of best fit that passes through the most deviated points above and below the line of best fit. Like in this case, our line of best fit is this one. So we now draw a parallel line that is passing through the most deviated point above. So we now get our I2 here. And likewise, we pass a parallel line that passes on the most deviated point below, and we'll now find I1 here. So when you do that, then you can substitute in the relationship and get. So to find your I1 and I2, you still use the slope and intercept formula. However, in this situation now, you impute the correct value of your origin that you use in plotting. So you impute the correct value of the origin. Now what you need to do is to count the number of millimeter boxes that starts from the origin to where the I1 and I2 are. So I can see 10, 20, 30, 40, 50, 60, and 68.5. I can see 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 188.5 as well. So you now come and find those intercept. To get the intercept I1, you put 68.5 here, and you can put just 0 there for the sake of computation. So you compute. That tells you that the intercept I1 is 0.2885. Now to find the intercept I2, you put 108.5 here, and you can put 0 here. Then you compute. That tells you that the intercept I2 is 0.3285. So you can now come and substitute in your relationship. If you do that and you evaluate, you will find the error on the intercept being 0.020, which is the same with your W. If you approximate to 2 decimal or 3 decimal places, you find out that it's the same with your W. So that will be the error on your intercept. I hope this is useful to you. You can find out more videos on how to use this app in plotting your graph, and you can download the app either from Google Play or any other place you may see it for your practical reporting. Bye.